Hello, everyone. I'm Christina Chai, and it is my great pleasure to be able to give this presentation today in this eOpen house. I am going to tell you a little bit about myself and also about the research of my group. And the title of my presentation is When Promiscuity Becomes a Virtue. This is a title that is intriguing, but nevertheless, I hope that at the end of my presentation, you will see how promiscuity seems to feature quite a bit in my research career. I'm going to start, like any good scientist, with a hypothesis. And my hypothesis is that academics are intellectually promiscuous. Why do I actually say that? Because this is really what happens in the brain of an academic. There are loads and loads of things floating around in the brain at any one time. So you have research, you've got teaching staff, you've got administration, and of course you have, in fact, normal life that you would need to contend with too. I'm going to also start now with an introduction of my own career. Let me begin with a partial life cycle analysis. I was born in Malaysia and I grew up essentially in Malaysia. So I did my primary school and my secondary school in Malaysia, except for the last year of my high school, which I completed in Wellington, New Zealand. From there, I carried out my undergraduate studies, which was a BSc Honours in Chemistry at the University of Canterbury, which is in Christchurch, New Zealand. When I completed my undergraduate degree, I then moved to the Australian National University to do a PhD under Professor Ethel Beckwith, who was one of the world's expert in free radical chemistry. When I completed my PhD with him, I took up a research fellowship at University of Oxford, the Dyson Parents Laboratory in the UK. And when I completed that, I took up my first academic appointment back in New Zealand at Victoria University of Wellington in New Zealand. I then moved to my second academic position, which is to the Australian National University, my alma mater. During this period of time, I had also spent short stints of time essentially in Germany as a DAD fellow and also as a von Humboldt fellow. From Australia, I moved in 2005 to Singapore. Interestingly enough, not to the university, but to A-Star. And at that time, the Institute of Chemical and Engineering Sciences was newly established, and they wanted someone to build a research program in organic chemistry. And that's basically what I did. In 2011, I moved entirely, essentially, to the National University of Singapore, the Department of Pharmacy. That's where I am now, and I'm currently the head of Department of Pharmacy since January 2016. I hope that this partial life cycle analysis shows you the different places that I have been and the different sort of experiences that I have gained. And also, if you think about it, the promiscuity in the different sorts of jobs that I have had. My primary area of research in the Department of Pharmacy is on bioactive compounds. And it starts basically with the design and synthesis of bioactive compounds. And then they are used essentially as probe or tools. And one specific project is on gene editing. And this is with Dr. Tan Meng Hao with the Genome Institute of Singapore in A-Star. And then we have also other bioactive compounds that are designed and synthesized to be applied to therapeutic areas, looking at the design of therapeutic drugs. Currently, we are interested in infectious diseases, anti-inflammatory diseases, and also CNS diseases. If you've looked at my past publications, we have looked at other disease areas, including cancer, and also regenerative medicine. But this just basically moves or changes, the therapeutic area changes um, every 4 or 5 years or so. I have collaborations with a number of colleagues within the university in pharmacology, in microbiology and immunology. I already mentioned Dr. Tan Ming Hao in GIS in A-STAR, and we have also quite a number of international collaborators. My secondary area of interest is essentially on biomimetic processes and materials and also detection methods. And here I work mainly with the engineers, okay? And so I have collaboration with Prof. Tong Yen Hua and Prof. Neo Kunji, and also with industry partners. So you can see that my promiscuity has actually spanned areas of medicine to basically areas of engineering. I'm going to talk a little bit more about my major area or my primary area of research, which is essentially on bioactive compounds. And specifically, I'm going to talk about lead identification. And of course, you know, or you might know, that there are many ways in which you're going to be able to find a hit compound, which can then be developed into a lead compound. And these includes looking at privileged motifs, looking at the literature and patterns, or you'll be able to do a rational drug design, and so on and so forth. But one of the key areas is essentially on natural products. This is I guess, a very popular way in the past of being able to find lead compounds, because traditional medicines is essentially based on natural products. We are also interested in natural products as lead compounds. This is not exclusive, because we actually carry out many different ways of being able to design lead compounds. But one of the areas that I'm particularly interested in is looking at natural products as lead compounds. They come from many different sources, right? And because of the fact, what I call the economy of nature, it is very unlikely that you have one natural product that only has one function. So it is often known that natural products have multiple targets and functions. And these can be shown, for example, in this molecule, resveratrol, which has been shown to have health benefits in cardioprotection, anti-cancer, anti-inflammatory, present in red wine, of course. And then you've got the flavonoids and the flavones found in fruits and vegetables, and is purported to target many different biological targets, giving rise to the therapeutic effects. I am fascinated with this. I am specifically fascinated with the fact that natural products have been reported anyway, or the bioactive components in natural products have been used in the treatment of many different diseases. And therefore, we ask the question whether we can exploit natural products for drug development. The next slide basically just asks the very question that I guess that you would want to ask if you just basically listen to my first slide, which is the title slide. And the question is whether promiscuity is in fact bad. When you look at drug development, it had often been thought for a very, very long time that a drug that is so-called promiscuous is in fact not going to be good. But basically, of late, in the last 10 years or so, people have started to realize that to have a drug which is selective may not be able to treat complex diseases like cancer. For those diseases, it might actually be best to be able to develop drugs which are in fact going to be promiscuous. Promiscuity in this context can also be said to be synonymous with multi-targeting. So promiscuity in natural products has the good, the bad, and the ugly. The ugly is something that everybody is always concerned with, whether when a compound is promiscuous, whether it will lead to undesired side effects, which can then lead to toxicity. Or alternatively, when you look at a natural product or a compound or any bioactive compound which is in fact going to be promiscuous, if you want to determine what is the exact target, it is going to be challenging. It is going to be hard to optimize desired activity because you have multiple parameters in which you are supposed to optimize. And also, if you think about the single target paradigm, which is the quest for a selective drug, is actually the way pharmaceutical companies develop their drugs. So there is, in fact, there needs, of course, to be a paradigm shift. The good aspects is really associated with the recognition these days that polypharmacology is really what is needed in drug discovery and development. And this just shows you a couple of our papers that we have published fairly recently, which actually outlines our research in this area, or rather our perspective in this area. And the first of which was published in Future Medicinal Chemistry in 2018, and it is basically entitled The Polypharmacology of Natural Products. And more recently, which is basically in press at the moment, in Natural Product Reports, shares our thoughts on the polypharmacology of andrographolide. Andrographolide is, in fact, a active component of a herb, Andrographolis paniculata. Actually, is a traditional medicine that is used even today. So I guess I wanted to share with you my thoughts on promiscuity. And you can tell that my career, I started basically somewhat being promiscuous in the research that I had carried out, in the roles that I have taken, and in the countries that I actually had worked in and lived in. In terms of my research, and that in fact translated to my research, which enabled me to be interested in many different areas. And even within the primary area of medicinal chemistry, I am actually pursuing this concept of promiscuity to see if we are going to be able to harness the promiscuity in terms of their polypharmacology to in fact develop much better drugs. I'd like to thank you for your attention. You can see that I'm somewhat connected through Twitter and LinkedIn, and you should feel free to explore my profile. Actually, to be honest, I don't really post that much, but at least you would be able to be part of my network. Thank you very much for your attention.